Welcome back to the channel. In today's video, we'll look at how to calculate the effective depth of a simply supported reinforced concrete beam, and determine whether the deflection of the beam is acceptable. Let's begin with a worked example. We have a 6-meter reinforced concrete beam that is simply supported. The beam was designed to support the roof of a double garage. The beam is 160 mm wide and 330 mm deep, with two 20 mm steel bars at the top and two at the bottom, as well as an 8 mm diameter link with a 25 mm cover. The beam is designed to resist a bending moment of 60 kN per meter. How will we determine whether the deflection of the beam will be acceptable? The first step is to determine the reinforcement ratio, which is the ratio of the area of steel provided to the effective area of the section. At the bottom, we have two 20 mm steel bars. The area of a 20 mm steel bar is equal to pi times 20 to 2 divided by 4, which equals 314 mm squared. As a result, the total area provided is 2 bars multiplied by 314 mm squared. This is equal to 628 mm squared. The effective depth, d, is equal to the depth of the beam, 330 mm, minus the cover, 25 mm, minus the link size, 8 mm, minus half of the bar size, 20 mm, divided by 2. This results in a value of 287 mm. We should now be able to calculate the reinforcement ratio, which is equal to 100 times the total area provided. Divide this by the effective area of the section, which is 160 mm times 287 mm. This gives us a value of 1.4%. According to Eurocode 2, the span effective depth ratio for a simply supported beam with 0.5% tensile reinforcement is 20, and the span effective depth ratio for a simply supported beam with 1.5% tensile reinforcement is 14. After interpolation, the span depth ratio is 14.6. In comparison, the actual span depth ratio is 6000 mm divided by the effective depth 278 mm. This results in a value of 20.9, which is greater than 14.6. As a result, the beam depth is unacceptable. Therefore, the effective depth should be greater than 6000 divided by 14.6, which equals 411 mm. In conclusion, the beam depth is equal to the effective depth of the beam, 411 mm, plus the cover, 25 mm, plus the link size, 8 mm, plus half of the bar size, 20 mm, divided by 2. This gives a value of 454 mm. Round this up and use a beam depth of 460 mm. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.